Hi you guys, how are you? Thanks so much for watching this video. The first thing I need to tell you is that there will be no live class this week on Monday, Tuesday, or Wednesday. I am actually going to be down at the Murray office helping with testing. Um, I hope that some of you are also at testing. I would love to get a chance to meet you in person. We will still be having 3 new lessons this week. So I'm going to go through today's lesson during this video, and then I'll send out another video for Wednesday's lesson, and then there will be live class on Thursday, and we will have our 3rd new lesson for this week. Okay, so we're going to have 3 lessons this week, one right now in this video. I will email out a 2nd lesson on Wednesday, and then I will see you in live class on Thursday. Okay, so with that said, we're going to go ahead and get started with today's lesson, exponential expressions and equations. Okay, so in this class, we have been working on exponents and the properties of exponents. And so one of the things that you guys have learned is that 2 squared is 2 times itself twice. Okay, remember this is the base, this is the exponent or the power. The exponent tells us how many times we're going to use the base as a factor of itself. Okay, so 2 to the 2nd power is 4. 3 to the 2nd power, that means 3 multiplied by itself twice. 3 times 3 is 9. 4 raised to the 2nd power is 16. We'd know that 4 times itself twice is 16, okay? 5 to the 2nd power is 25. 6 to the 2nd power is 36. Okay, now I had quite a few of you who were multiplying the base with the exponent. Please do not do that. Okay, remember that the exponent tells you how many times you're going to multiply the base by itself. Okay, so with that said, another thing we need to talk about today, something new, is square rooting. Okay, square rooting is the opposite of squaring. Okay, so when we have a base raised to the 2nd power, we would say we are finding the square. Okay, so 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. Okay, so when you're raising a base to the power of 2, we can say that we are squaring that base. So the opposite of squaring is taking the square root. Okay, and when we take the square root, we're trying to figure out what number multiplied by itself gives us the number that is underneath the radical sign. Okay, these right here, this is called a radical sign. Okay, so when we take the square root, we're trying to figure out what number do we multiply by itself, or what number do we square to get to 4. Okay, and we know that that would be a 2. 2 squared is 4. Okay, let's look at the next one. The square root of 9. We're trying to figure out what number do we square that will give us a 9. So what number multiplied by itself twice gives us a 9? We know that answer is a 3. Okay, we know that 3 squared is equal to 9. Let's look at the next one. What number squared gives us 16? Okay, so we're trying to figure out what number multiplied by itself gives us a 16. And we know that answer would be 4. Okay, 4 squared is 16. So the square root of 16 is 4. Okay, let's look at another one. The square root of 25 is 5. And that's because 5 squared is 25. Now let's go ahead and look at the last one, the square root of 36. So we're trying to figure out, what do we multiply by itself to get to 36? We know that that would be a 6. Okay, 6 squared is 36. Now, one way to write the square root is to use a radical sign. Okay, we can also use a rational exponent to show the same thing. Okay, so the square root of 4 equals 2 is the same thing as raising 4 to the power of 1/2. Okay, so that also equals 2. So the square root of 9 equals 3. If we raise 9 to the 1/2 power, that is the same as taking the square root. Okay, so 9 to the 1/2 power is 3. We're just writing it as a rational exponent instead of using the radical sign. Okay, so if we have the square root of 16, another way we can write that is 16 raised to the 1/2 power, and that answer would be 4. If we have the square root of 25, another way to write that is 25 to the 1/2 power, and that would be 5. Okay, let's say we have 36 to the 1/2 power. That's the same thing as the square root of 36, and we know that that answer would be 6. Okay, so if we have the square root of 100, we're trying to figure out, what do we multiply by itself to get to 100? So the square root of 100 would be 10, and that's because 10 squared equals 100. Okay, now another way that we can write the square root of 100 is 100 to the 1/2 power. That would also be 10. Okay, these are the same. This is the radical form, and this is using a rational exponent. So let's look at another one. Let's say we have, or if I ask you to find the square root of 49. So that means, what is multiplied by itself to get to 49? And that would be a 7. Okay, we know that 7 squared equals 49. Okay, so the square root of 49 is 7. Another way we can write this is 49 to the 1/2 power, and that also equals 7. Okay, let me show you one more. Let's say we have the square root of 64. So if we're finding the square root of 64, we're trying to figure out, what number can we multiply by itself to get to 64? Okay, so what can we square to get to 64? And that would be 8. 8 squared is 64. Okay, we can also write this as 64 to the 1/2 power, and that also equals 8. Okay, exponents can also be a 3. So we would call this cubed. So if we take 2 and we raise it to the 3rd power, that means we are going to multiply 2 by itself 3 times. So 2 times 2 times 2 equals 8. Okay, 3 to the 3rd power. That would be 3 times 3 times 3. That would be 3 times itself 3 times. Okay, and that would be 27. 4 to the 3rd power. That would be 4 times itself 3 times. 4 times 4 times 4 is 64. Okay, if we take the base of 5 and we raise it to the 3rd power, that's going to be 5 times 5 times 5, which is 125. And then the last one, 6 to the third power, that would be 6 times itself 3 times, okay? We have 6 times 6 times 6, and that does equal 216. Now, the opposite of cubing, or raising to the third power, is taking the cube root. Okay, so we can see here that the cube root of 8 is 2. The cube root of 27 is 3. Okay, so when we're taking a cube root, we're trying to figure out what do we multiply by itself 3 times to get to this? And that answer would be 4. Okay, what did we multiply by itself 3 times to get to 125? And that answer would be 5. What did we multiply by itself 3 times to get to 216? And that answer would be 6. Okay, so the opposite of raising to the third power is taking the cube root. Okay, now writing this expression, the cube root of 8, is the same thing as writing it as 8 to the 1/3 power. Okay, they're just written in different forms. This one is the radical form. This is the rational exponents form. So if we want to write the expression, the cube root of 27, we could rewrite that using a rational exponent as 27 to the 1/3 power. Okay, so if we want to write the cube root of 64 using a rational exponent, we would write it as 64 to the 1/3 power. If we want to write the cube root of 125, we would write it as 125 to the 1/3 power. Okay, if we wanted to use a rational exponent. For this last example, if we want to write the cube root of 216 not as a radical expression, but using a rational exponent, we would raise 216 to the 3rd power. Okay, so let's go ahead and try one here. Let's say we have the cube root of the cube root of 27. So we're trying to figure out what did we multiply by itself 3 times to get to 27? And that answer would be 3, okay? 3 cubed is 27. 3 times 3 times 3 is 27. So when we take the cube root of 27, we're trying to figure out what did we multiply by itself 3 times to get to 27, and that answer would be 3, okay? Another way that we can write this using a rational exponent is 27 to the 1/3 power. Okay, let's go ahead and look at another one. Let's say we have, I'm trying to come up with one that is even. So let's say we have 8, the cube root of 8. So we're trying to figure out what was multiplied by itself 3 times to get to 8. Well, that would be 2 times 2 times 2, okay? So 2, when we take the cube root of 8, we get 2, okay? 2 is the number that was multiplied by itself 3 times, okay? We know that 2 to the 3rd power is 8. And another way to write this would be 8 to the 1/3 power. Okay, now In this example, we have an expression that is written using a rational exponent. Okay, so if it has a fraction, we would call that using a rational exponent. If it has the radical sign, then we would call that using the radical. Okay, so we have 16 to the 1/4 power. We know that that's the same thing as taking the 4th root of 16. Okay, let me go ahead and this should be written a little smaller. There's like a little teeny 4 here. There we go. That looks better. Okay, so 16 to the 1/4 power, and the fourth root of 16. This is asking the same thing. It's asking, what do we multiply by itself 4 times to get to 16? Okay, and we know 2 times 2 times 2 times 2 equals 16. Okay, 2 to the 4th power equals 16. So the answer to both of these would be 2. 2 is the number that when you multiply by itself 4 times, you get to 16. Okay, let's look at the next one. 100 raised to the 1/2 power. This is the same thing as the square root of 100. And most of the time in math, if it's a square root, we don't write the 2 here. Okay, so we would just write it as the square root of 100. So we're trying to figure out, what did we square to get to 100? Or what was multiplied by itself twice? And that answer would be 10. Okay, 10 squared is 100. So 100 to the 1/2 power is 10. And the square root of 100 is also 10. Okay, remember that these are the same, they're just written differently. So let's go ahead and look at the last one. 25 to the 1/3 power. Okay, so this would be the same as the cube root of 125. Sorry, that looks really bad. 125. So what was multiplied by itself 3 times to get to 125? And that would be 5. 5 times 5 times 5 is 125. So the cube root of 125 is 5. Okay, so now I'm going to take something that I hope is not super confusing, and we're going to add one more thing to it, and then we're going to practice some problems. Okay, so property of rational exponents. This is an important property that you need to know, and it says that when you have a base raised to a fraction, okay, you can see that the bottom number of the fraction becomes your root, and the top number of your fraction becomes your exponent. Okay, so let's go ahead and look at this one right here. 8 to the 2/3 power. If we want to apply this property, okay, if we want to take it from a rational exponent to a root, we take the bottom number of the fraction, that becomes the root. The top number of the fraction becomes our power that it is raised to. Okay, so 8 to the 2/3 is equal to, okay, you can see that the bottom number of the fraction becomes our root, and then the top number of the fraction becomes our exponent. So 8 to the 2/3, when we rewrite that, it becomes the 3rd root of 8 squared. Okay, let's look at this one. 16 to the 3/4 power. Okay, this becomes the 4th root of 16 raised to the 3rd. Okay, now to figure out what this is, 8 to the 2/3, We need to figure out what the cube root of 8 is. So what do we multiply by itself 3 times to get to 8? And that would be 2. And then 2 squared equals 4. Okay, so 8 to the 2/3 power equals 4. Okay, let's go ahead and look at the next one. 16 to the 3/4 power. So if we want to figure this out, we have to figure out what do we multiply by itself 4 times to get to 16? And that would be a 2. Okay, and then we have 2 raised to the 3rd power, which is 2 times 2 times 2, which is an 8. Okay, let's look at another one. 27 to the 2/3 power. Notice that we take the bottom number of the fraction, that becomes our root, and the top number of our fraction, that becomes our exponent. So the cube root of 27, what do we multiply by itself 3 times to get to 27? That would be a 3, and then 3 squared equals 9. Okay, let's look at this next one, 32 to the 3/5 power. Notice this gets written as 5, okay, the root of 5. So the 5th root of 32 raised to the 3rd power. So what do we multiply by itself 5 times to get to 32? And that would be a 2. Okay, so inside of our fraction, that becomes a 2. And then 2 raised to the 3rd power, 2 times 2 times 2 is 8. Okay, now we are going to go the other way. So we're going to go from a radical expression to a rational expression. So notice that the root, that becomes the bottom of our fraction. The exponent, that becomes the top of our fraction. So the 4th root of 81 raised to the 3rd power becomes 81 to the 3/4. Or the 5th root of 32 to the 2nd power becomes 32 to the 2/5. Okay, if we have the 4th root of 6 raised to the 3rd power, that becomes 6 to the 3/4. Okay, so let's see if we can go back and forth here. Let's say we have 7 raised to the 2/3 power. Okay, so remember the bottom number of our fraction, that tells us the root. The top number is our exponent. So this would be the cube root of 7 raised to the 2nd power. What if we have the 5th root of 10 raised to the 4th? Okay, and we want to take this to a rational. We want to rewrite this using a rational exponent. This would become 10 to the 4/5 power. Okay, so just to always remember, your root is the bottom number of your fraction, and the exponent is the top number of your fraction. Now, before we go any further, we need to have a review about multiplying fractions. And I know that maybe it's been a while since you have done this. Okay, so when you multiply fractions, if there is anything that can be simplified, you take care of doing that first. Okay, so we know that 2 can go into 2 one time. And then after we've simplified, we multiply top times top over bottom times bottom. So 1 times 1 is 1. 1 times 3 is 3. Okay, for the next one, 1 times 1 is 1. 4 times 2 is 8. Okay, let's look at another one. For this one, there is nothing that we can simplify here. There's nothing in the top that can divide into anything on the bottom evenly. So we just do top times top over bottom times bottom. That's how you multiply fractions. So 4 times 2 is 8. 5 times 3 is 15. Okay, on this one, it's a whole number. To make a whole number or fraction, you put it over 1, and then you would do top times top over bottom times bottom. So 2 times 3 is 6, 1 times 4 is 4, 6/4. Now, I actually forgot to simplify first here, so let me back up. 2 can go into 4 2 times. So we would have 1 times 3 is 3, 1 times 2 is 2. If you don't simplify in the beginning, so like if you take 2 over 1, you multiply it by 3 over 4, and you get 6 over 4, you need to simplify when you're done. So 2 goes into 6 3 times, 2 goes into 4 2 times. Okay, so either way you do it, if you simplify first and then multiply, or multiply and then simplify, you still get the same answer. Okay, so let's go ahead and practice a few more of putting something that has a rational exponent in radical form, and then we're going to practice putting something in radical form to something that has a rational exponent. So 10 to the 5/4, we would write this as the 4th root of 10 raised to the 5th power. Okay, -3 raised to the 2/3 power. This would be the cube root of -3. Notice how I'm leaving it in the parentheses, and then squared. Okay, let's look at the next one. 2 to the 1/6 raised to the 3rd. Now we have to be careful here because we have something being raised to a power. We have 2 being raised to a power, and then we have another power. So this is power of a power. So remember from last week, whenever you're raising a power to another power, you have to multiply the 2 exponents. Okay, this is the power of a power. So this would be 2 to the 3/6. And then 3/6, that's a fraction that actually simplifies. 3 goes into 3 once, 3 goes into 6 twice. So this actually becomes 2 to the 1/2 power, which we know that that is the same as the square root of 2. Okay, so let's go back to our problems here. We took care of doing each one of these. Now we are going to take something that's in radical form and put it in rational exponent form. So we know the bottom number of our fraction is going to be 4. The top number of our fraction is going to be 5. 6 to the 5/4 power. Okay, let's look at the next one. 5th root of -2 to the 3rd power. So -2, this would be to the 3/5 power. Okay, this one's a little bit more tricky. So let's go ahead and do this one. The cube, we're going to do what's in the parentheses first. Okay, we always follow the order of operations. So we do what's in the parentheses first. To write the cube root of 7 to the 4th power in rational exponent form, this would get written as 7 to the 4/3. Okay, then we need to raise that to the 1/2 power. Okay, so again, this is a power of a power. So we're going to multiply 4/3 with 1/2. 2 goes into 4 twice. 2 times 1 is 2. 3 times 1 is 3. That becomes 7 to the 2/3 power. Okay, you guys, that is it. I know that that was really maybe confusing to some of you, and I'm so sorry we don't have live class today, but there is really good news. Math Lab is open today from 11 to 1. Math Lab is also open tomorrow from 11 to 1. And so If you need some more help with this, I'm really sorry I'm not available, but I know that Mrs. Kohler can help you in Math Lab. Okay, so you're not alone. I didn't leave you stranded. You do have someone to help you. What I want you to do is instead of taking a quiz, I'm going to have you do these 8 practice problems for me. And this is what you will turn in to the Dropbox. Okay. For questions number 1, 2, 3, and 4, you are going to express in radical form. Okay, so that means you're going to give it a radical. For questions 5, 6, 7, and 8, you are going to remove the radical and write it in rational exponent form. Okay, so these are your problems. You can go ahead and take care of doing these problems, put it in the Dropbox, and then your next new lesson will be on Wednesday, and I will send you another recording for that. Remember, Math Lab is today from 11 to 1 or tomorrow from 11 to 1. If for some reason you're not caught up on all of your lessons for this class, please take care of doing that this week. Okay? I hope you guys have a really, really awesome day. And yeah, I hope to see some of you at testing. And if I don't, I will see you on Thursday. Talk to you later.